Honors Geometry, looking at homework 16.2, radian angles. The directions for the first four problems: draw an angle with a given measure and standard position. Once again, what makes radians more complicated than degrees is fractions. So let's do this. Let's mark each of these quadrantal angles using pi over 6 as a base. So at the beginning, on the positive x-axis, we get 0 pi over 6. Hopefully you know by now if you make a complete revolution, that's 2 pi. That's the same as 12 pi over 6. Halfway between 0 and 12 pi over 6 would be 6 pi over 6. Halfway between 0 and 6 would be 3 pi over 6. Notice the relationship. The numerator for each quadrantal angle increases by 3 pi each time. 3 pi, 6 pi, and it's going to be 9 pi over 6. Then add 3 more and you get 12 pi over 6. Pi over 6 clearly falls between 0 pi over 6 and 3 pi over 6. So the angle that we're supposed to draw is going to be here in quadrant 1. Perhaps I made that too thick. And that makes this angle here pi over 6. Specifically, pi over 6 is the same as 30 degrees. Pi is 180. 180 divided by 6 is 30. That's the same as 30 degrees. Number 2, we got negative 5 pi over 3. I would mark my quadrantal angles in the negative direction by pi over 3's. So we got 0 pi over 3. Complete revolution is 2 pi, or negative 6 pi over 3. We're going in the negative direction. So if we go halfway around, it's going to be negative 3 pi over 3. That's the same thing as negative pi. Halfway between 0 and negative 3 is negative 1.5 pi over 3. The numerator is decreasing by 1.5 each time. So we're going to get negative 4.5 pi over 3. And then from here, hopefully you can see that negative 5 is going to fall between negative 4.5 and negative 6. So our angle is going to look like this. Negative 5 pi over 3. Number 3, we got 3 pi over 4. I'm going to mark my quadrantal angles. We got 0 pi over 4. Halfway around is pi, which is 4 pi over 4. Halfway between those is 2 pi over 4. So the numerator is increasing by 2 each time. So we get 6 pi over 4 here. When we get back to the beginning, we're going to have 8 pi over 4. 3 falls between 2 and 4. So this is going to be in quadrant 2. Number 4, we got negative 12 pi over 5. So that's in the negative direction. So if we got 0 pi over 5, and then negative 5 pi over 5 is halfway around. Negative 10 pi over 5 is completely around. Halfway between 0 and negative 5 is negative 2.5 pi over 5. The numerator is decreasing by 2.5 each time. So we get negative 7.5 pi over 5. Subtract 2.5 more, we get negative 10. Now at this point, we haven't gone far enough, because negative 12 pi over 5 doesn't fall between any of these numbers. So if we continue, this next quadrantal angle is going to be negative 12.5 pi over 5. Both of these are referring to this negative y-axis. So the angle that we're making makes a complete revolution and then stops just short of the negative y-axis. This is negative 12 pi over 5. You could have also found a coterminal angle with this. Well, yeah, let's not do that. Let's leave it as it is. 5, 6, 7, 8. Find the measure of each angle and make sure it's in radians. So there's lots of ways to approach this. I'm going to mark, since this is over 3, I'm going to mark my quadrantal angles by pi over 3's. So we got 0 pi over 3 here at the beginning. Complete revolution is 6 pi over 3 because that reduces to 2 pi. Halfway around is pi, or 3 pi over 3. Halfway between 0 and 3 is 1.5 pi over 3. So 0, 1.5, 3, 1.5 more. This would be 4.5 pi over 3. And that's going to be good enough. So the distance from here to here is 4.5 pi over 3. Plus we have one more pi over 3. That's going to make this 5.5 pi over 3. Typically in math, we don't like an angle, we don't like a fraction to have a decimal in it. So we could multiply the top and bottom of this by 2 if we wanted, same as multiplying by 1, and that would give us 11 pi over 6. We would much rather see the answer written this way than 5.5 over 3. Is it terrible if you do it this way? It's not. It's just better if you write it like this. Number 6, since I see this fraction over 4, I would suggest strongly that we mark our quadrantal angles by pi over 4s. And since this angle is going in the negative direction, we will do this in the negative direction. We get 0 pi over 4. Complete revolution is 2 pi. And the negative direction is negative 8 pi over 4. Halfway around is negative 4 pi over 4. Now at this point, we probably have enough. Because if we look at what's happening, if we go all the way to here, it's negative 4 pi over 4, but we are short of it by pi over 4. That must mean this is negative 3 pi over 4. 1 pi plus 3 pi is 4 pi. That would make this whole thing. So that is our answer for 6. 7, see if we can figure this out without doing any work here. A complete revolution is 24 pi over 12. We are short of that by 11 pi over 12. That's going to make this 13 pi over 12, and we're going in the negative direction. If that's not satisfying to you, let me label the quadrantal angles by pi over 12. So we got 0 pi over 12, complete revolution, which is 2 pi. We're going in the negative direction. That would be negative 24 pi over 12. Halfway around will be negative 12 pi over 12. Let's see. What we could figure out then from this, if it's 11 pi over 12 to here, that means that this little gap that we're missing, it must be 1 pi over 12. And then hopefully you could see that if we have negative 12 pi over 12 plus another pi over 12, we get 13 pi over 12. Number 8, this makes a complete revolution, so the answer is bigger than 2 pi. And then we go a little bit more, so let's label these quadrantal angles by pi over 18. We got 0 pi over 18. It's going in the positive direction. If we double that, that's 36 pi over 18. That's the same as 2 pi. Halfway around would be 18 pi over 18. Halfway between 0 and 18 is 9 pi over 18. So that's probably enough for us to figure this out. The complete revolution to here gets us 36 pi over 18. And then from here to here is 9 pi over 18. We've used 5 pi over 18. That must mean this here is 4 pi over 18. Because 5 pi over 18 plus 4 pi over 18 is 9 pi over 18. So our answer to this is 36 pi over 18 plus 4 pi over 18, which is going to give us 40 pi over 18. You can divide the top and bottom by 2 to reduce and get 20 pi over 9. So that's what we would declare for that answer. 9 through 12, state the quadrant in which the terminal side lies. If it's asking for the quadrant only and not to actually draw the angle, first of all, you probably should still draw the angle. But we can use coterminal angles if the angle we're given is bigger than 1 revolution. So I could leave the angle like this. This is clearly bigger than 2 pi, because if 4 is on the bottom and 8 was on the top, 8 pi over 4, excuse me, that would be 2 pi. So I'm going to subtract from this a complete revolution. It's a revolution. If I do that, I'm going to get 7 pi over 4. So these are not the same angles, but they do have the same terminal side. This is a coterminal angle. So if I draw on the coordinate plane, and I label my quadrantal angles by pi over 4s, because this fraction is over 4. Complete revolution's 8 pi over 4. Half a revolution is 4 pi over 4. Halfway between 0 and 4 is 2 pi over 4. And that would make this 6 pi over 4 down here. So 7 pi over 4, 2 pi over 4, 4 pi over 4, 6 pi over 4. 7 pi over 4 is going to be halfway between 6 pi over 4 and 8 pi over 4. So to answer the question, which quadrant, this is in quadrant 4. Number 10, 5 pi over 6. If you go big picture for this, hopefully you know at this point that half a revolution is pi. Pi is the same as 6 pi over 6. This is just short of 6 pi over 6. So this is going to be in quadrant 2. If you need more of an explanation, start out at the beginning at 0 pi over 6. Halfway between 0 and 6 is 3 pi over 6. 5 pi over 6 clearly falls between 6 pi and 3 pi. Number 11, this is within 1 revolution. I'm not going to find a coterminal angle. We're going to go in the negative direction. Work with me here. From here to here, in negative direction is negative pi, which is the same as negative 9 pi over 9. We're supposed to go negative 10, which puts us just a little bit higher. It's going to put us in quadrant 2. If you need more of an explanation, we got 0 pi over 9. Complete revolution is 2 pi, which is 18 pi over 9. Halfway between 0 and 18 is 9 pi over 9. Halfway between 0 and 9 is 4.5 pi over 9. And I've made a mistake here. This is the negative direction, so I should have negatives for these. My apologies. The numerator is decreasing by 4.5 each time, so we'd have negative 13.5 over 9 up here, pi. Negative 10 falls between negative 9 and negative 13.5, so we're in quadrant 2. Number 12, this is more than 1 revolution because the top number is a bit more than twice as big as the bottom number. That tells you it's more than 1 revolution, because 1 revolution is 2 pi, which means 2 pi over 1. The top number is twice as big as the bottom without the pi. So I'm going to find a coterminal angle for this by adding a complete revolution. This is going to be negative 5 pi over 6. So in the coordinate plane, if I go in the negative direction, negative 5 pi over 6 is just short of negative 6 pi over 6, which is going to fall in quadrant 3. All right. 13 and 14. Find one positive and one negative coterminal angle with the given angle, and clearly we're supposed to be in radians. So we got to find a positive coterminal angle and a negative coterminal angle. Coterminal angles are complete revolutions apart. 1 revolution is the same as 2 pi. If you want common denominators, that's going to be 6 pi over 3. That's going to give us 7 pi over 3. Pi over 3 and 7 pi over 3, their terminal sides would terminate in the same location. To find a negative coterminal angle, we're going to subtract a complete revolution or multiples of complete revolutions. So this is a possible answer for that. There are an infinite number of correct answers for 13, depending on how many revolutions you choose. Number 14, I'm going to add a complete revolution, and using radians, this is going to have to be 8 pi over 4, because I want common denominators. That's the same as 2 pi. That's going to give me 13 pi over 4. If I subtract a complete revolution, we're going to get negative 3 pi over 4. This also has an infinite number of correct answers, depending on how many revolutions you chose. Find a coterminal angle between 0 and 2 pi. We first want to figure out, is this bigger than this range or is it less than this range? It's bigger because 9 over 4 is bigger than 2. So to find a coterminal angle, we are going to take the angle we're given and subtract a revolution or multiple revolutions to get us in this range. We want the numbers in front of the pi, if you divide them, to be between 0 and 2. So one revolution is 2 pi. Getting common denominators, it's 8 pi over 4. If you subtract these, you get pi over 4. In other words, 1/4 of pi. 1/4 is between 0 and 2, so that checks out. There's only one correct answer for 15. 16, this is also bigger than one revolution. Using 2 as a denominator, one revolution would be 4 pi over 2. So to find a coterminal angle, we could take 13 pi over 2 and subtract a revolution as many times as we need to. I'm going to subtract a revolution. If I do that, I'm going to get 9 pi over 4. Is this less than 2? It is not. So I'm going to have to subtract another revolution from this. And I get 5 pi over 2. I'm sorry, I made a mistake up here. When you subtract fractions, the bottom number should not change. 1,000 pardons. Really sorry about that. This also is not between 0 and 2 pi because 5 divided by 2, that's bigger than 2. So if we take this and subtract another revolution from this, we're going to get pi over 2. Now, you could do this in a different way if you wanted. If you can see big picture, what's happening here, you can take 13 pi over 2 and subtract 3 revolutions at the beginning. This 12 divided by 2 is 6 pi. That's 2 pi plus 2 pi plus 2 pi. This is 3 revolutions. If you're a visionary, you can do it that way, and I'm cool with it. See on the back side. Convert each degree measure into radians. So we got 225 degrees. We're going to use dimensional analysis that we would use in a science class. Going to write it as a fraction. We want the degrees to cancel, so we need degrees on the bottom. And we want to use some type of unit of measure that we know are equal to each other. For example, 180 degrees is the same as pi radians. The degrees cancel, so now we're in radians. We can divide both 225 and 180 by 45. 45 goes into 225 5 times. It goes into 180 4 times. It's going to make this 5 pi over 4 radians. If you don't write radians, it's fine. It's assumed to be in radians. 20, 280 degrees. We're going to change to radians. We want the degrees to cancel. Pi radians, which is half a revolution, is the same as 180 degrees, which is also half a revolution. We can divide top and bottom by degrees. We can divide top and bottom by 10. We got 28 over 18, and we can divide both of those by 2. and this ends up being 14 pi over 9 radians. Number 21, note this is a negative angle, so our answer should be negative as well. So negative 210 degrees times pi over 180 degrees. The degrees cancel. We can divide both negative 210 and 180 by 30. 30 goes into negative 210, negative 7 times, goes into 180 6 times. That's going to make this negative 7 pi over 6. 22, we got negative 1020 degrees. Going to multiply it by pi radians over 180 degrees. We can divide the top and bottom by degrees and 10. 102 and 18, we can divide both of those by 2. You get negative 51 over 9. And I can divide both of those by 3 and get negative 17 thirds pi. 23 through 26, convert each radian measure into degrees. So we got negative 5 pi over 9. For emphasis, I'm going to just write radians here. I want the radians to cancel, so I got pi radians on the bottom, and I have 180 degrees on the top, because this is equivalent to 1. So what does that do for us? Well, the pi's cancel, and the radians cancel. 9 goes into itself once, goes into 180 degrees 20 times. So now we have negative 5 times 20 degrees, which is negative 100 degrees. 24, we got 5 pi over 6. I'm going to write radians for emphasis. We want the radians to cancel. Pi radians is the same as 180 degrees. Pi divided by pi cancels. Radian divided by radian cancels. 6 goes into itself once. 6 goes into 180 degrees, 30 degrees times. We got 5 times 30 degrees, which is 150 degrees. 25. 23 pi over 36. Radians for emphasis. We're going to multiply this by 180 degrees over pi radians. Radians cancel. Pi's cancel. 36 goes into itself once. 36 goes into 180 degrees 5 degrees times. Now we have 23 times 5 degrees, which is 115 degrees. Just when you thought it couldn't get worse, we got 79 pi over 18. Going to multiply this by 180 degrees over pi radians, because we want the radians to cancel. Radians cancel, pi's cancel. 18 goes into itself once, goes into 180, 10 degrees times. We have 79 times 10, which is 790, and the units is degrees. All right, this last part. Take a sip here. Oh, that's delicious. Some people really freak out when they see an angle measurement in radians without pi. Trust me, that is not an exaggeration. Don't freak out. Remember, pi is just a number. So for right now, let's just pretend that pi is 3.14. So this happens to me all the time in pre-calculus. People see this too, and they think, well, that's got to be degrees. I don't see a pi beside it. You don't need a pi beside it. There's no degree symbol, so that's in radians. Let's mark our quadrantal angles. So we got 0, 2 pi, pi, pi over 2, and 3 pi over 2. If we then take a calculator and we calculate what these things are, pi over 2 is about 1.57. Pi is about 3.14. 3 pi over 2 is about 4.71. And 2 pi is about 6.28. Now, if you write it in decimal form, this is super easy. 2 falls between 1.57 and 3.14. So that means that 2 is over here, 2 radians. That's it. If we go to B, this is a negative angle. So if we go in the negative direction, we got 0, negative 1.57, negative 3.14, negative 4.71. Negative 1.2 is between 0 and negative 5.7. So this is going to fall into quadrant 2. Number 5, if we label these in the positive direction, we got 0 radians, 1.57, 3.14, 4.71, 6.28. 5 falls between 4 and 6, so that puts us here in quadrant 4. All right, hopefully you enjoyed that as much as I did.